we have covered almost all of the topics. Now, this is the last topic, and there will be a few subtopics in it. The topic is colligative property. Colligative property. Colligative property. Okay. Now, there is one suggestion from my side. Okay, there is one suggestion from my side for those, especially for those who are preparing for NEET. Okay. अच्छा, इसमें I just want to see if just wait a second, है ना? एक ऐसी बच्ची थी जिसको हमको 4 बजे बुलाना था. She was in the 6:30 batch. Let me just remind someone to ask Memuna to join. Please ask. Okay. Now my suggestion will be once we have done, once we are completely done with this chapter, then you will open up your previous year questions, right? We'll open up the previous year questions. Okay. My suggestion will be start from colligative property. Once you have done, because we have done complete theory, all of the theory we have done already, the theory of solution chapter. This is the last part, colligative property, and previous year questions in which you will have chapter wise, topic wise. Now, then there will be colligative property, and before that there will be ideal solution, non-ideal solution. Those type of topics will be there. But the problem what happens with student, they start very बहुत जोश रहता है ना सबको. They start with the first, that is concentration term. Okay, they will start with the first one, that is concentration term. Now, after concentration term, they will went to solubility. They went to solubility. Third, they went to ideal, non-ideal, ideal and non-ideal. Then fourth, they went to, now in solubility, they will have Henry's law, you will have Raoult, so all of these things, right? Fourth, they went to colligative property. Now, the number of students who reach colligative property is itself very low. Is itself very low. Very less number of students, they start from concentration term and they end up till colligative property. You need a consistent, need to have a consistency there. So what I suggest is you start with colligative property if you have the theory clear. If you have done NCERT, you complete the NCERT and the assignments, and after that, from previous year questions, you start with colligative property. Why? Because most of the questions, they come from these two topics, ideal, non-ideal, and colligative property. And recently, colligative property is the one which they are exploring more often. So इससे क्या होगा, जो पैटर्न है उसके हिसाब से आपके सवाल बनेंगे. ठीक है? So do this thing after we are done with the whole chapter. Okay? ऐसा नहीं कि आपने concentration term पढ़ा ही नहीं है और colligative property के सवाल बनाने लगे. ठीक है? चलिए. So we'll write colligative property. Now, what is colligative property? What is colligative property, or what are colligative property? So the properties which depend on, अच्छा एक और चीज आप लोग को थोड़ा सा बताते हैं, how the colligative property is different from whatever we have learned till now. Whatever we have learned till now. So you have learned about Henry's law, which says that pressure is equal to Kh into chi b. We have learned about Raoult's law, which says that pressure of A will be equal to P naught of A into chi A. Yes or no? Please tell me. These are the things that we have studied.
Yes.
Correct. Now, in both of these things, you will see that this is the property. It is, and this is a property. These two are property. It is dependent on the amount of solute, the amount of solute, as well as the nature of solute, as well as the nature of solute. See, Kh and P naught A. Kh will be different for different gases. P naught A, that will be different for different type of A, right? If you have water and if you have ethanol, the vapor pressure of pure water and pure ethanol will be different. Okay, so all of these things, they depend on the amount of solute that you are adding, the amount of a component of a particular component that you are adding into a solution, and it also depends on the nature. And what is the solute or what is the component that you are taking in solution. But now what we are going to learn, about colligative property, and these are the properties which depends only on the amount that is added. Okay, amount that is added in the solvent or the solution. Okay, so first of all, we will write the definition. What are the What are colligative properties? Now, this definition itself has been asked many times, so this definition is also very important. Please write with me the properties of solution which depend only on the number of solute particles. Only on the number of solute particles. Okay. So this complete definition, it was asked in, I think, CBSE exam only somewhere in 2017 or 18. And now next point is, if they are only dependent on, they are only dependent on what? Only dependent on the number of solute particles. Okay. That means we can write colligative property colligative property is directly proportional to number of particles in solution, number of particles in solution, and which means that it will be inversely proportional to the molar mass of solute. It will be inversely proportional to molar mass of solute. अब ये बताइए, how many of you understood this relationship? Number of particles and the molar mass. How many of you understood this relationship? How is number of particles in solution inversely proportional to molar mass of the solute? How is number of particles inversely proportional to molar mass? Okay, all of you, no one understood. Okay, how many of you did not understand this?
Like number of moles?
Number of moles का मतलब क्या हुआ? हम आपसे ये पूछे कि आपने कितने दर्जन अंडे लिए, क्या आपसे हम ये पूछे आपने कितने अंडे लिए? Both of the things same, yes or no? Correct है? If I ask you, है ना, this is right. Mole, what is mole? Mole is like dozen only, ना? Mole is like dozen only. What is mole? Mole is 6.022 into 10 to the power 23. कोई भी चीज होगा. If you have 1 mole of pen, that means you have this much amount of pen. It is same as dozen only, right? So that is why. इसका मतलब ये है, if you take 5 gram of something, है ना, you have A and you have B. A का जो molar mass है, that is, let us say, it is 100 grams per mole, and B का जो molar mass है, that is only 50 grams per mole. And we have taken for both of these things, we have taken how much? We have taken, let us say 100 grams of A and 100 grams of B. Now in 100 grams of A, we will have only one. That means we'll have 6 into 10 to the power 23, है ना, 6.022, approximately 623 molecules of A. अगर हम B की बात करें तो उसमें कितना हो जाएगा? It will be 12 into 23, right? So from here you can see, if we have same masses, if we have same mass, then number of particles of a solution will be inversely proportional to the molar mass, है ना? अगर molar mass कम है तो आपका number of particles ज्यादा हो जाएगा. Okay, that is the only thing that I meant by number of particles in solution is inversely proportional to the molar mass of the solute. Is this thing clear with everyone? Yes or no? Please tell me.
Yes. Yes.
Okay. Now there are four different colligative property which we are going to study one by one. Okay. So please write me. There are 4 colligative properties. Okay. Number one is relative lowering of vapor pressure. Relative lowering of vapor pressure. इसका क्या मतलब होता है? मतलब इसका शॉर्ट फॉर्म होता है RLVP. Its short form is RLVP. Second is depression in freezing point. Depression in freezing point. Okay, how many of you have How many of you have had kulfi? Please raise your hand now. Kulfi कितने लोगों ने खाया? Okay. Okay, many of you have. Okay, not many. बहुत कम लोगों ने कुल्फी खाया है क्या? Okay. अच्छा, still not many people have had. जर्श, आपने कभी कुल्फी ही नहीं खाया है? हाँ जर्श, नवाल, मिनाशी, मासी, खलील, आपने कभी कुल्फी नहीं खाया है? हाँ खलील, ओके जर्श, ओके गाइस, एम आई ऑडिबल? आप लोग हाँ ना कुछ जवाब ही नहीं देते हैं. Oh, Khalil is not connected. He got disconnected. Okay, fine. Many of you have had. अच्छा. Now keep your hand raised अगर आपने ठेले में खाया है. If you understand what a ठेला is. Keep your hand raised if आपने ठेले में खाया, like देसी बिल्कुल गांव में. Not in some ice cream parlor वाली जगह में नहीं. No one has had. Okay, fine. तो आप लोग को नहीं सर.
I didn't understand what you were asking.
ठेला का मतलब होता है ऐसे बाजार में there is a guy who is like who has a cart kind of thing, and in that he is selling kulfi.
No, like from shop itself.
From no, not from shop. I mean from some like desi type of thing. Okay, Hania has. Okay, Hania ने खाया है. Okay, fine. अच्छा, खलील ने खाया है. Okay. ये क्या हो गया? इतनी दूर पे चले गया. Okay. Maybe. अच्छा. How many of you found something like थोड़ा salty type का end में? Have you ever found कुल्फी थोड़ा सा salty? Hania, you have found? हाँ? Yes, Hania? No. कोई नहीं. Khalil. Khalil, can you please turn the mic on? नहीं, सैयद मोहम्मद ने सिर्फ खाया जिनको थोड़ा सा नमकीन लगा हो. ओके, सैयद मोहम्मद, कैन यू प्लीज टर्न द माइक ऑन इफ यू कैन.
Yes, sir.
हाँ, आपने खाया, कहाँ खाया था कुल्फी जो थोड़ा सा आपको नमकीन लगा हो? एंड में या फिर जहाँ पे स्टिक रहता है वहां पे?
Yeah, sir. Almost every time I go to India.
एवरी टाइम यू गो टू इंडिया थोड़ा सा नमक
Yeah.
रहता है ना?
Yeah.
ओके, ठीक है. एंड दोज हु हैव नॉट हैड ना, यू आस्क योर पेरेंट्स. ठीक है, आप अपने पेरेंट्स से पूछिएगा कि कुल्फी में जब खाते थे गांव में तो थोड़ा सा नमकीन लगता था क्या? एंड we will then talk about depression and freezing point. Okay, this has some relation to depression and freezing point, है ना? So the kulfi wala, he knows about depression and freezing point. We will see how. चलिए. So one of the tasks that you have is to ask your parent about kulfi that they have had from India or Bangladesh for Khalid and Salman. Okay. Next, the third one is elevation in or of boiling point. Elevation in boiling point. The last one is osmotic pressure. The last term is osmotic pressure. Okay, so first of all, we'll learn about the relative lowering of vapor pressure. We'll learn about relative lowering of vapor pressure. No, relative lowering of vapor pressure is like very easy. It is very much similar to what we have studied in Raoult's law. Okay, so write the topic relative lowering of vapor pressure. Okay, so the thing is the relative lowering, first one. Relative lowering of vapor pressure. Okay, now before writing anything, let me explain what is the relative lowering of vapor pressure. We have seen solutions, and in solution we have seen three types. So here we are having, there is liquid plus gas. Gas is the solute. Okay, then we saw liquid and liquid. Then we saw liquid plus liquid. Now we are going to learn about liquid plus solid. Okay, liquid plus solid. Now always remember all of these things, whatever I am telling now. Liquid plus gas, liquid plus liquid, liquid plus solid. तीनों में क्या होगा? In all of these three, you will have some vapors which is present above the solution in all of these three. ठीक है. Now in the first one, liquid and gas, what do we have in the solution? We have liquid and gas. Yes or no? Please tell me. In the solution we have liquid and gas, right?
Yes.
Now which has a tendency to escape more, liquid or gas? Which will escape more easily, liquid or gas? बताइए.
Yes.
All of you agree, yes or no? Nawal, Mazia, Darsh, Maimuna, Khalil, Khalid. Liquid,
Yes.
Yes,
gas
sir.
will, है ना? Gas will escape more. That is why we have Henry's law, in which the pressure is only dependent on the gas. Chi V देखिए, है ना? Gas is the solute, है ना? This is Henry's law. अच्छा, जब liquid और liquid रहेंगे, so both the liquids will have equal tendency to escape, yes or no? They will have equal tendency to escape, correct है?
Yes, sir.
Right? And that is why here we have the Raoult's law, which says that P total will be equal to P naught A chi A plus P naught B chi B. And this we can easily say that it is dependent on both of these, it is dependent on what? It is dependent on both of the liquids. It is dependent on both of the liquids. But when I look at the liquid plus solid, now you tell me which has a tendency to escape, liquid or solid?
Liquid.
Liquid.
Only liquid, right? Solid will not, will solid escape? Will it ever
No.
escape? No, right? So in that case, we will have the pressure that will be only due to the liquid that is present. Huh? That will be due to the liquid that is present in the solution, that is present in a solution. Okay. So write that. Okay, you have written relative lowering of vapor pressure. Huh? Write the definitions and all, and after that, we will derive further relationship. Now, so first thing, when it is applied, when a non-volatile, solute, when a non-volatile solute is dissolved in a solvent, vapor pressure of the solvent, okay, sorry, of the solution, I can say, because once we have added it, it becomes solution. Vapor pressure of the solution becomes lower than that of pure solvent, which is known as relative lowering of vapor pressure. Okay, Rlvpp, relative lowering of vapor pressure. Okay, now here we have a solution. Okay, here we have a solution, and there will be some vapors. Okay, and the pressure that will be present here, it will be directly proportional to what? It will be directly proportional to chi A only. Yes or no? Chi A means the mole fraction of solvent that is liquid. It will be only dependent on chi A, which means it will be dependent on, it will be equal to P naught A chi A. Is that right? Yes or no? Please tell me. यहाँ तक समझ में आया सबको?
Yes.
Yes or no?
Yes, sir.
Now it is very easy. So the P total, this is P total now. Why? Because the pressure will be only due to A, and this is the P total. You can write P total will be equal to P naught A. Chi A नहीं लिखते हैं. We always define solution. We always define solution by the concentration of its, of its solute, है ना? ऐसा नहीं, चीनी अगर पानी में आप बोलिएगा, पानी पी के कोई बोलेगा नहीं पानी थोड़ा कम हो गया, पानी डाल दो, बोलेंगे चीनी ज्यादा है, right? So we always define things in the terms of the solute, है ना? चीनी ज्यादा है, चीनी कम है, right? चाय पत्ती ज्यादा है, चाय पत्ती कम है. P naught A, what I will write? 1 minus chi B. I will write, instead of chi A, I will write 1 minus chi B. Okay. Now what we can do? We can say, okay, fine, this is P total, this is P total, and this is P naught A. This is P total, and this is P naught A. Now we will see what is the difference between What is the difference between, we can write it like this, P total is equal to P naught A है ना minus P naught A chi B. Correct है? P naught A chi B. Yes or no? Please tell me.
Yes, sir.
Okay. Now what I will write? I will write the difference between. First we will see the lowering of vapor pressure. Okay. Lowering of vapor pressure. Lowering of vapor pressure का मतलब जो pressure before था, what was the pressure before adding the solute? Before adding the solute, the pressure was equal to how much? The pressure was equal to P naught. And now the pressure is equal to how much? It is equal to P. Now it is equal to P. And this is equal to how much? This will be equal to P. ये P total है आपका. P naught A की जगह हम क्या रख देंगे? P naught A ही रख देंगे. P total की जगह हम क्या रखेंगे? Minus of P naught A minus P naught A chi B. अच्छा, ये लाइन सबको समझ में आया? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
I'll make it easy for you guys. ठीक है, चलिए. Now moving on. We can write P naught A minus P naught B total as delta P. The difference in pressure. The difference in pressure, which will be equal to P naught A minus P naught A. It will become what? 0. Yes or no?
Yes, sir.
Correct. So now what we can write? It will be equal to P naught A into chi B. So lowering of vapor pressure is equal to how much? The lowering of vapor pressure is equal to P naught A chi B. The lowering. Now we have the relative lowering. Relative lowering of vapor pressure. Now the lowering is happening to a relative point. What is the point? The point is P naught. The point is P naught A. So relative lowering will be equal to what? Relative lowering will be equal to, if you divide this by P naught A and both the sides. So delta P, right, is right, delta P upon P naught of A will be equal to chi B. This expression, it represents the relative lowering of vapor pressure. Okay. ये जो है आपका expression, it is giving me lowering of vapor pressure. This is giving me relative lowering of vapor pressure. Relative lowering of vapor pressure. Okay. Please write this down. Delta P upon P naught A is equal to chi B. Remember this conclusion point, the result.
Sir, could you show the definition part again?
Sure. Done. Is there anyone who is still writing?
No, sir.
No? Okay. You write a note here, an important note. अच्छा ये बताइए, आप ही लोग बताइएगा, है ना। Lowering of vapor pressure, that means delta P, it is dependent on the, it is dependent on what? It is dependent on P naught A, and P naught A will change if I change the solid, right? If I change that, sorry, if I change the liquid, then the P naught A will change. That means what type of liquid is present, what type of liquid is present in the solution, it is also determining the lowering of vapor pressure. But if I look at the relative lowering of vapor pressure, which is this point, it is only dependent on the amount of solute. It is only dependent on the amount of solute. It is not dependent on what is the solute or what is the mixture, what are the components in the solution. It is not related to that. It is not even dependent on that. Okay, that is why the note that you will write here is relative lowering of vapor pressure is a colligative property. But lowering of vapor pressure is not a colligative property. Is not a colligative property. Now, देखिए, how we can determine the molar mass, है ना? How we can determine the molar mass through Rlvp. So you can write this as a topic also, determination of molar mass using Rlvp. एक चीज याद रखिएगा, this is for dilute solutions only. For dilute solutions. ठीक है, for dilute solutions. So what we are doing, what we did, we took a solvent. हमने क्या ले लिया? हमने क्या ले लिया? वो पानी ले लिया, H2O, right? And then we added something here. Okay, we added something. Let us say A. We measured the pressure, that is P naught A. And after that, here we put a barometer or manometer. We measured the P total. Then we took the ratio of both of these things, P total upon P naught A, and P total upon P naught A. So we got one of the values. We got one of the values. So what is Rlvp? Rlvp is equal to, we change this part, P total upon P naught A. This will be equal to P naught minus P total upon P naught, है ना? एक लिख लेते हैं जो कि आपका सॉल्वेंट होगा. This will be equal to chi b. What is chi b equal to? Chi b is equal to number of moles of B upon number of moles of A plus number of moles of B. Number of moles of A plus number of moles of B. Now, since we have a dilute solution, in this we can say that, in this we can say what? Number of A is very, very, very higher than number of moles of B. And if number of moles of A is very, very, very higher than number of moles of B, then we can write this point, P naught A minus P. If P A nahi hoga, my bad, this will be P total upon P naught A will be equal to, now we can neglect the B part from denominator and we will write NB upon NA. NB upon NA. What is NB? NB is nothing but it is equal to the given mass of B upon the molar mass of A. And a molar mass of A multiplied by what is NA? NA will be equal to the given mass of A divided by the molar mass of A. The molar mass of A को हम ऊपर रखते हैं यहाँ पे. Molar mass of A will be here. Okay. So W, ये यहाँ पे, sorry, ये B होगा यहाँ पे. Given mass upon molar mass of B into the molar mass of A upon the given mass of, to the given mass of A. Okay. So what are the given mass? We can already know. WB, WA, दोनों हम लोग लगा सकते हैं अंदाजा कितना होगा, because we are making that solution. What we don't know is this part, that is MB. What will be the molar mass of B? And that we can calculate. Simple से experiment हम लोगों ने क्या किया? Simple से experiment किया हम लोगों ने. We had water. इसका हमको P naught A पता है. We know what is the P naught A for water. Then we did what? We added some solute. And after that we measured from barometer manometer what is the P total. We took the ratio P naught A minus P total upon P naught A. We got some value, and that value we equated with this particular thing where we have the given mass, we have the molar mass of this solvent, because we already know what solvent is, so we can write the molar mass, but we don't know what is this B molecule. What is this B molecule, and that is why we can determine what is the B molecule using this formula of the Rlvpp. Okay. Now we will do some questions. Please write this down. Please write this down. We'll do some questions now. जब तक आप लोग इसको लिखे हम तब तक सवाल लिख देते हैं आप लोग के लिए. Please write with me. A solution is prepared by dissolving solution is prepared by dissolving 10 gram of non-volatile solution. 10 gram of what? 10 gram of non-volatile solute होगा ना, sorry. In 200 grams of water. It has a vapor pressure of 31.84 mm Hg at, let us say, 308 Kelvin. Calculate the molar mass of solute. Okay, we need one thing. Vapor pressure of pure water is equal to 32 mm of Hg. Done. चलो, let us write the solution here. आसान सा simple formula based सवाल है, ठीक है? And if this question comes, this will come in 3 marks. Similar type of question, it has come many times in CBSE examination, where you have to calculate the molar mass of solute. Everything is given, है ना? आपको क्या क्या दिया हुआ है? 10 ग्राम आपके पास नॉन वोलेटाइल solute है ना? 20 ग्राम आपके पास क्या है? 200 ग्राम का पानी है. Then you have the vapor pressure of what? Solution is 31.84 mm of Hg. Pure water कितना है? 32 mm of Hg. So right, according to Rlvpp, relative lowering of vapor pressure के मुताबिक the P naught of A minus P total upon the P naught of A will be equal to mole fraction, right? Will be equal to mole fraction, or rather we can say will be equal to what we have written first here. We have written WB upon MB into MA upon WB. MA upon WB. Now we can just put up the values, plug in the values here. What is W of A? यहाँ पे A होगा What is W of A? It is equal to 200 grams. WB is how much? 10 grams. What is the molar mass of A? Water का molar mass होता है 18 grams per mole. What is the molar mass of B? यही तो find करना है. And this is what we have to find out. Now what is P naught A minus P total? P naught A will be equal to 32 mm of Hg. 32 minus 31.84 divided by 32. Divided by 32. This will be equal to WB is 10 upon MB into MA कितना है आपका 18 upon 200. 18 upon 200. ठीक है, कैलकुलेट कीजिए इसको कितना आ रहा है. MB क्या हो जाएगा आपके लिए? MB will be equal to 10 into 18 upon 200 into 32 minus 184. नहीं, 32 minus 31.84 divided by 32. Divided by 32 ऊपर चला जाएगा. इसको छोटे ब्रैकेट में कर देते हैं. चलिए प्लीज कैलकुलेट कीजिए इसको. आंसर कितना आ रहा है बताइए.
Sir, could you show the question again? I was disconnected.
क्वेश्चन देखना है आपको. नीचे देखिए क्वेश्चन. सैयद मोहम्मद करेक्ट. Yes, Matthew, correct. 200 into 16 will be equal to how much? 16 to 32 है ना. होगा ये 1 हो जाएगा.
Okay, okay. Yeah. 200.
32 होगा ना. 32 होगा ना.
Okay, okay. Never. Okay.
ये दोनों को काट दीजिए आप. आंसर हो गया आपका 180 ग्राम पर मोल. ठीक है, अब ये बताइए व्हाट इज दी सल्यूट. सल्यूट क्या होगा? व्हाट विल बी द सल्यूट? क्या हो सकता है सल्यूट? 180 ग्राम
ग्लूकोज.
ग्लूकोज. वेरी गुड है ना. तुक्का मारने के लिए आएगा. 180 के लिए तो कुछ भी हो सकता है, बट अगर ग्लूकोज हुआ तो ग्लूकोज में मारिएगा, है ना.
Will they ask like that?
ना, आई एम जस्ट सीइंग लाइक होता है ना कभी कभी. एक सवाल पूछ लिया उसमें और उस सवाल की चर्चा हो रही है पूरे साल भर कि क्या सवाल पूछ लिया, कुछ दिया ही हुआ नहीं था. हम उस केस की बात कर रहे हैं. ठीक है, इन एक पेपर में एक सवाल ऐसा आ गया, पागल हो गया टीचर, सोल्यूशन चैप्टर से ही पूछ दिया उसने. ठीक है, दैट टाइप 5 साल में एक बार ऐसा सवाल आ सकता है. उन केसेस की बात कर रहे हैं. Done guys, all of you please tell me yes or no.
None, sir.
Okay, Hania is done. Can I move? Yes or no? Please tell me.
Yes, sir.
Okay. So there is one thing that we will make a graph. Okay. So graph for Rlvp. Relative lowering of vapor pressure. Now in this graph, we will plot against. Here we'll be having the pressure. Okay, here we'll be having the pressure, and here we will plot for the mole fraction of A. Okay, this is mole fraction, solvent ka mole fraction. Now when at this point of time, chi A will be equal to how much? 0, and chi B will be equal to 1. At this point we have only solute which is solid, है ना? We have solid. ठीक है, आपने क्या रखा हुआ हाथ में? हाथ में आपने क्या रखा हुआ? ग्लूकोज रखा हुआ. Glucose will have no vapor pressure, right? It will have no vapor pressure. And at this point in the plot, here we are having what? Here we have chi A which is equal to 1 and chi B which is equal to 0. So यहाँ पे आपके पास जो plot होगा वो कुछ इस तरह का आएगा. So from 0, and this is reaching P naught of A. ठीक है? It's very simple graph. This point here is the P naught of A, the vapor pressure of pure A, or vapor pressure of pure solvent. Vapor pressure of pure solvent. Please write this down. Done, guys. Can I move on? Yes or no? Please tell me. आगे बढ़े.
Yes, sir.
Next लिखिए. Elevation of boiling point. Elevation of boiling point. ठीक है, अब ध्यान से सुनिएगा, ध्यान से है ना. Please don't write here. Please listen. In this case, we have pure H2O. ठीक है, और यहाँ पे हमने क्या डाला हुआ है? H2O plus glucose. ठीक है, we are not doing anything. Everything is simple. We are not doing anything. You can say that this is P naught of A, and this is P total. ठीक है, here we have glucose and water, and here we have just glucose. अब ये बताइए कौन सा बड़ा होगा, P naught A या P total? Which will be higher? Where will we see more vapor, in pure H2O या फिर जहाँ पे हमने solid डाला हुआ है? Pure H2O. P naught A will be higher, right? P naught A will be higher. That means here we are having more vapor, and vapor pressure is more here. Now you tell me which of the following, A or total, है ना? Which of the following, solvent or the solution, which will require which will require more temperature to reach pressure is equal to 1 atm. बताइए किसमें आपको टेम्परेचर ज्यादा देना पड़ेगा?
Sir, solution.
है ना, टोटल वाले में, सोल्यूशन वाले में, दैट इज द एलिवेशन ऑफ बॉइलिंग पॉइंट. सबको समझ में आई बात? यस और नो प्लीज टेल मी.
Yes.
Yes.
ओके, ठीक है, सिंपल. एलिवेशन इन बॉइलिंग पॉइंट, है ना. व्हाई इट इज हैपनिंग? बिकॉज वी आर एडिंग अ नॉन वोलेटाइल सॉल्यूट. ठीक है, अ नॉन वोलेटाइल सॉल्यूट. नाउ व्हाट इज बॉइलिंग पॉइंट? Boiling point is the temperature at which the vapor pressure of liquid is equal to the atmospheric temperature, the atmospheric pressure. The atmospheric pressure. Now, next point is, as the vapor pressure, wait a second, as the vapor pressure of a solution with non-volatile solute is always lower than that of pure solvent. Hence, this solution requires higher temperature to attain a vapor pressure that is equal to atmospheric pressure, leading to an elevation in boiling point. Leading to an elevation in boiling point. Is this understood? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Then all of you, yes or no? Please tell me.
Yes, sir.
Okay. अब यहाँ पे ना आपसे एक बार रीजन पूछा जाएगा, है ना. Although it is quite evident, है ना, it is quite evident that if you will add some solute, then obviously the vapor pressure will be lower. But still they will ask you why it is getting lowered, है ना. So why is the vapor pressure getting lowered? है ना, उसी को explain करने के लिए what we will do, we will take two containers. ठीक है, we are going to take two containers. And here we have having pure liquid. ठीक है, there is a similar case, but here we have solvent plus solute, and this solute is solid. ठीक है, this solute is solid, so obviously it will be occupying some space, है ना. ये हमने बस रेड दिखा दिया है, ऐसे रेड तो दिखेगा नहीं कुछ, है ना, बट फिर भी, and there are molecules, है ना, in the surface also. There will be some molecules in the surface. Now, as you can easily see, that the only molecules which will be evaporating or escaping the liquid will be the molecules which are present on the surface. Now, once we add some solute particles, what is going to happen? The number of solvent particles present in the surface of the liquid will be lower. They will be less, right? They will be lowered, and that is why what will happen? The number of vapor molecules forming will also get lowered, and that is why the vapor pressure will be lower, and that is why the vapor pressure will be lower. Is that understood? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Adding of solid solute, adding of solid solute occupies some space on the surface of liquid leading to what can we say? Leading to less number of solvent particles escaping to vapor phase. Which leads to lowering in vapor pressure. Tell. Done, everyone? Yes or no? Please tell me.
Done, sir.
Okay. Look at done now. We will look at graph for elevation in boiling point. ठीक, ग्राफ ध्यान से एक बार समझ लीजिएगा, ठीक है? एक बार समझ लीजिए, एक बार में समझ में आएगा. आपने अगर टाइम लगा दिया यहाँ पे ना, यहाँ पे टाइम नहीं लगना चाहिए. ध्यान से सुनिए, पेन साइड रखिए. Now, first thing, whenever we put up a graph, we will tell you what are the coordinates. So we are measuring the temperature. Okay, measuring the temperature. Now, temperature will measure always in Kelvin scale, right? Scientists, Kelvin scale. Then, in the y coordinate, we will measure the vapor pressure. Measure the vapor pressure. ठीक है? क्या करना है? बॉइल करना है. अब अगर आपको कोई चीज को बॉइल करना है, कहाँ पे रह के? चांद पे नहीं, दुनिया में रह के. If you have to boil something on earth, then you have to mark this point of 1 atm, है ना? सही है? अगर वेपर प्रेशर 1 atm पहुंच गया तो बल्ले बल्ले हो गए. That means boil हो गया. What will happen? It will start to boil, right? It will start to boil. Okay. So what I will do, I will plot this and I will say that, okay, fine. This is the 1 atm, है ना? This is the 1 atm. तो ठीक से ही कर देते हैं आप लोग के लिए. Line for 1 atm. अच्छा. And let us suppose that the normal temperature is somewhere here. The normal temperature is somewhere here, and we are just having a solvent. No? We are just having solvent. Let us suppose the vapor pressure is here. And if I increase the temperature, then what will happen? If I am increasing the temperature, the vapor pressure will increase or decrease? It will increase. It slowly increases. मेरा hang कर गया. Oh no, it is working. No, my keyboard is not working, guys. Wait a second. Oh, this is bad news. Okay, my thing is not working. Walk off. Wait a second, huh? Oh no, this is working. My system got hacked. Oops, 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 oops. Who was the host?
Me.
Oh, Khalid was the host. Okay. Thank you for letting me in. Okay. कहाँ तक आप लोगों ने सुना? Tell me. You got this point of red now. What is this red point? Red point is the temperature at which we have. This is the normal temperature. ठीक है? 25 डिग्री सेल्सियस मान लीजिए केल्विन के हिसाब से आपका लगभग 300 केल्विन है ना? We are here, and we are having only solvent now. When we will increase the temperature, what will happen? The vapor pressure will increase, and it will reach to 1 atm like this. Is that understood? Yes or no? Please tell me, guys. Is it understood? Yes or no?
Yes, sir.
Okay. Now, when we will take the solution, its vapor pressure will be a bit lower, है ना? Its vapor pressure will be a bit lower, and that is why when I will increase the temperature, it will reach the 1 atm here. It will reach the 1 atm here. And now what we want to do? We just want to drop a line. This line will be for. This line is for the solution. Okay. And you will have the red line that will be for solvent. Oops, sorry. Okay. Now you guys tell me which will be higher temperature, red or green? कौन सा टेम्परेचर ज्यादा होगा, रेड वाला या ग्रीन वाला?
Green.
Green, sir.
Green one, right? And green is for solution. Red is for solvent. चलिए, I hope you have drawn the graph.
Yeah.
Yes. Okay. Now, let us now also formulate it. Right? We will formulate what is the elevation in boiling point. What is the elevation in boiling point? Let us suppose if T naught B is the boiling point of pure solvent and TB is the boiling point of solution. It is the boiling point of what? It is the boiling point of solution. Then we can say that delta TB, this will be equal to, which is higher, TB is higher, so TB को पहले लिख देते हैं minus T naught B, है ना? Because the difference will always be positive. तो difference होता है आपका हमेशा हम लोग positive में लेके चलते हैं ना. What is the difference in temperature? Okay. Now we also know if I add more solute, तब क्या होगा? If I add more and more solute, then what is going to happen? The vapor pressure will be very less. If the vapor pressure will be very less for the solution, it will require higher and higher temperature. That means the difference between the boiling point of pure solvent and the boiling point of solution will be even more higher, right? It will be even more higher. That means delta TB I can write will be directly proportional to the concentration of solute. Now the concentration terms which really matches and which really does the job is molality. So delta TB, we say that it is proportional to molality. Delta TB, and it is okay. My host privileges are back. Okay, fine. Delta TB is equal to, we can write now, there will be a constant KB times molality, and the molality is short for molality will be M, right? Short for molality will be M. Okay, so what is KB? This is the formula now. You have to remember this. Delta TB is equal to KB into M. Okay, what is KB? KB is known as molar elevation constant. Elevation constant. Okay, there is one more name. Its name is boiling point elevation constant. Acha. Is there any other name that you guys know of?
Sir, I think one more is there. I think
one more is there.
constant.
Spelling कोई बता दे भाई please. Ebulioscope, right? EBULLIO scopic constant. Ebulioscopic constant. Ebulioscopic constant. इनको भी लिख लीजिए, बाद में आप लोग खुद लगता रहेगा सर M क्या है सर यहाँ पे. It is molality. It is molality. What is delta TB? Delta TB is TB minus T naught B. यहाँ तक तो हम लोगों ने देख लिया बिल्कुल आराम से. तो क्या करेंगे? Again we will do what? We will calculate the molar mass of solute using elevation in boiling point. अब देखिए ये भी कितना आसान है. Molar mass, we are calculating molar mass, which is a molecular level thing, है ना? Which is a molecular level
Sir,
thing.
could you show the formula again, please?
Yes, sure. लिख लीजिए आराम से. यहाँ पे रहते रहते एक और चीज लिख लेते हैं ना. What will be KB? KB will be equal to delta TB upon M, है ना? यानी कि जो यूनिट हो जाएगी KB की क्या हो जाएगी? The unit will be equal to delta TB. Delta TB will be in Kelvin, है ना? Difference in temperature will be in Kelvin.
Kelvin per kg mole.
Kelvin पर kg मोल नहीं होगा, kg पर मोल होगा. मोलालिटी का क्या होता है? नंबर ऑफ मोल्स डिवाइड बाय अगेन केजी, उससे केजी ऊपर चला जाएगा ना, तो केल्विन केजी पर मोल, केल्विन केजी पर मोल। चले, okay, now you guys will write what is molality. What is molality? Molality is equal to, you want to hear slogans? Gram Panchayat election is going to happen in our village. Can you guys hear it?
Yeah, sir.
I don't know what is the use at night time. गर्मी बहुत है ना, that is why they are having a march in night time. छोटा सा गांव है, इसमें ज्यादा लोग को ले आए हैं। Fair. It is now, what is molality? Molality is equal to given mass of solute, है ना? Number of moles लिख लेते हैं पहले, number of moles of solute divided by the mass of solvent in kg, which will be number of moles will be equal to how much? The given mass upon the molar mass of solute, right? Divided by WA in kg, W in kg. Now what we can do? We can write W of A in grams and divide by 1000 also, right? Divided by 1000. Now all of these things will be in terms of whatever, if this WA is also in grams, right? Then this will become in kg. Okay, this will become in kg. All of you understood this point, yes or no? What is WB? WB is given mass of solute in grams. MB is molar mass of solute in grams. Okay. What is WA? WA is mass of solvent in grams. Mass of solvent in grams. Mass of solvent in grams. Okay. Now what we are going to do? We are going to put this M in the formula of delta TB. So we know that delta TB. इसको थोड़ा सही से लिख देते हैं आप। This 1000 will go above, right? This 1000 will go above, and this MB will come down. This will be equal to 1000 into WB upon 1000 into WB upon WA into MB. Okay, this is what molality. This is your molality. So delta TB will be equal to whatever the KB is into 1000 into WB. That means the given mass of solute divided by W of A into the molar mass of B. Into the molar mass of B. Now you can see that we can write MB is equal to how much? MB will be equal to, इसको हम यहाँ ले गए, डेल्टा टीबी को वहां ले गए, तो KB into 1000 into WB divided by WA into MB, अरे WA into delta TB, sorry, delta TB को यहाँ लाना था, ठीक है? So you write this down. Now these things are very important if you think about them in the practical sense. Delta TB के लिए आपको क्या चाहिए? थर्मोमीटर, ठीक है? W के लिए आपको क्या चाहिए? You have to have a mass balance, या फिर आपके पास कोई measuring tool होना चाहिए. You can measure tool, है ना? तो इलेक्ट्रिक का अब तो आने लगा है ना, you can measure WB, ये भी, इसके लिए भी आपको क्या चाहिए? You need some kind of balance, है ना? Balance ले लेते हैं. Here also you need balance, है ना? 1000 तो 1000 है, 1000 तो 1000 है. KB आपको कहाँ से मिल जाएगा? KB मिल जाएगा आपको डेटा बुकलेट बस, and you can now know the molar mass of something. So experimentally if you see, it is very unique. It's very beautiful and very easy in how you can calculate the molar mass of anything. एक सवाल है आप लोगों से, the value of KB depends on solute, B. Solvent, C. Solution, D. None. Please write the answer in chat. What will KB depend on?
Solvent.
Correct. It will only depend on solvent. Okay. ये याद रखिएगा, KB will depend on solvent. Water का कोई एक constant होगा, that will be molar elevation constant, है ना, molar boiling point elevation constant और Rayleigh square constant. It will never depend on solute. ठीक है, अगर ये solute पे depend करता तब तो ये क्या हो जाता, it would have not been a colligative property. That is why B will be the answer. Okay, solvent is the answer. Write this down, then we'll do one question. We'll look at the two, that is depression and freezing point. Sure. I don't know whether I can take your class next 2 तारीख ना, ट्यूसडे को तो हम आपकी क्लास लेंगे, थर्सडे के दिन नहीं ले पाएंगे. ट्यूसडे के दिन आई थिंक आई शुड कंप्लीट द सिलेबस. Done all of you? So now please tell me. Yes. Okay. Write a question. 18 gram of glucose. 18 gram of glucose is dissolved in 1 kg of water. 1 kg of water in a container. At what temperature? At what temperature will this solution boil? At what temperature will this solution boil? And it is giving you the KB for water. It is equal to 0.52 Kelvin kg per mole. Okay, kg per mole. Shall you please write this question? So 18 gram of glucose, it will give me the number of moles of solute, that is B, which is equal to the given mass divided by the molar mass. Given mass is equal to 18 grams. Molar mass is equal to 180 gram per mole for glucose. And you will calculate this one. And 1 kg of water, ये तो आपको दिया ही भाई 1 kg. So what are you getting? WA, है ना? So from now, both of these things, what you can find, the molality. Molality will be equal to number of moles of B divided by WA in kg. ठीक है? ये आपको मिल जाएगा molality. After that, what you have to find? You have to find the delta TB. क्या होता है? Delta TB will be equal to TB minus T naught B, which will be equal to KB into molality. You have already got the molarity. You have already been given the KB. अच्छा, now in the chat, tell me what will be delta, what will be T naught B. Chat में बताइएगा what will be T naught B. T naught B की वैल्यू क्या होगी? What will be the value for T naught B? Okay. Now it is correct, sir. otherwise I was just going to, okay, हाँ सलमान correct. What will be T not B? जिनको दिक्कत हो रही है, जिनको लग रहा है दिया ही नहीं है सवाल में, हाँ समायरा करेक्ट. वो क्या करे, T not B को क्या बोलते हैं, है ना? Try to see that equation in terms of words. In terms of word, T not B is an expression or is the term used for what? TB is a term that is used for what? Speak and then you will know. By the way, Samaira and Zarsh start मत कर दीजिएगा, ठीक है ना? Whatever the temperature that is, it will be in terms of Kelvin. ठीक है, ध्यान रखिएगा इस चीज का. ओके, बहुत ही कम लोगों ने बताया हमें. Still waiting for many answers.
Sir, what's the question again? To find NB or to find molality?
वो नहीं फाइंड करना है, कुछ फाइंड नहीं करना. What is T not B? I am asking. What will be the value for T not B? चैट में बताइए. See, we can calculate molality. KB is given, है ना? KB is given, and we have to determine the value for TB, है ना? जो solution का आपका boiling point होगा. अब ना तो T not B दिया है सवाल में, ना ही आप उसको कैलकुलेट कर सकते हैं कहीं से, है ना? मोलालिटी को यूज करके. नाउ आई एम आस्किंग व्हाट विल बी द वैल्यू फॉर T not B, है ना? एक इक्वेशन में दो वेरिएबल तो होंगे नहीं, है ना? यू कैन नॉट फाइंड TB एंड T not B आल्सो. सो व्हाट विल बी द वैल्यू फॉर T not B, ये फाइंड करना है. फाइंड क्या करना, बताना है. आप लोगों को सबको पता है. हाँ खालिद सही है. ओके, सो खालिद, समायरा, सलमान, जर्श. ओके, बहुत लोगों ने नहीं दिया आंसर. यस मैथ्यू, व्हाट डू यू थिंक? मैमुना, खलील, हानिया, हिश्मा. हानिया, can you please turn the mic on?
Yes, sir.
What is T not B? I'm not asking what is the value of T not B, लेकिन T not B किसको रिप्रेजेंट करता है? It is a boiling point, है ना?
Yes.
किसका? सोल्यूशन का या फिर प्योर सॉल्वेंट का?
Pure solvent.
प्योर सॉल्वेंट क्या है यहाँ पे?
Glucose. No, water.
अब आ गई बात समझ में? T not B कितना होगा?
1.
हाँ
0.52.
हाँ, घबरा गई हैं हानिया. अगेन, what is T not B, हानिया?
Boiling point of pure solvent.
What is pure solvent?
Water.
That means it is the boiling point of,
Water.
है ना? तो कितना होगा?
100 degrees Celsius.
हाँ केल्विन में लेंगे, है ना? We will keep this in
Yeah.
Kelvin, है ना? बाकी लोग को 373, हाँ 273 प्लस 100, आराम से. ओके, आई थिंक ऑल ऑफ यू हैव अंडरस्टूड दिस. यस और नो? खलील, मैमुना, माजिया, मीनाशी, नवाल. यस और नो गाइस?
Yes, sir. Yes, sir.
है ना? ठीक है, ध्यान रखिएगा इन सब चीजों का. ये सारी चीजें दिए नहीं रहेंगी, ठीक है? दे भी सकते हैं. आई हैव सीन सम ऑफ द CBSE क्वेश्चंस, दे गिव यू कि बॉइलिंग पॉइंट ऑफ प्योर सॉल्वेंट इज 373.15 केल्विन, है ना? देन यू हैव टू कैलकुलेट. चलिए, अब बहुत आसान हो गया आप लोगों के लिए. व्हाट इज TB? TB विल बी इक्वल टू T not B प्लस KB into M, ठीक है? प्लीज कैलकुलेट, गिव मी द आंसर. जल्दी कैलकुलेट कीजिए इसको. नंबर ऑफ मोल्स कितना हो जाएगा आपके पास? दिस विल बी अपॉन 10 ना. सो 1/10 मोल. सो molarity will be equal to how much? 1/10 only na. 1/10 will be the molarity. This is 373 लेके चलते हैं. Plus what is KB? KB is 0.52 into 1/10. This will be equal to 373 point छोड़ देते हैं plus 0.052 ना. तो यहाँ पे 373.15 ले लीजिएगा, ठीक है? Take this as 373.15. नहीं नहीं 15 ले लीजिए, फिर तो आपको बॉइलिंग पॉइंट जो आप आंसर में लिखिएगा दैट विल बी इवन लेस देन वाटर, अगर 373 लेके चलेंगे तो, है ना? दैट इज यू राइट 373.15, दैट इज द एग्जैक्ट वन. सो नाउ वी कैन, दिस विल बी इक्वल टू हाउ मच? 10 और 20 हो गया, तो 373.202, which will be equal to, I can say, 373.2 Kelvin. Okay, so this will be the increase in temperature. This will be the boiling point of water if you add only 10 grams of glucose. Done guys, yes or no, please tell me.
Yes, sir.
So, yes, सवाल लिखिए, अगला
Yes.
सवाल लिखिए. चलिए, let us do one more question. Please write this with me, okay? Solution of glycerol C3H8 O3 in water was prepared by dissolving some glycerol in 500 grams of water. The solution has boiling point of 100.42 degrees Celsius. 100.42 degrees Celsius. What amount of glycerol was added to make this solution? Okay, this is very important. Very important question. This has been asked 3 times in CBSE. Okay. If you talk in terms for board, then for the board people, it is very important. It has been asked 3 times, as it is, है ना? And this has been asked for 3 marks. 3 marks का जनरली सवाल होता है आपका बॉइलिंग पॉइंट से. यहाँ पे सबसे पहले आपको क्या फाइंड करना है? यहाँ पे यू विल फाइंड फर्स्ट ऑफ ऑल दी मोलर मास इसका फाइंड कर लीजिएगा, ठीक है? सो व्हाट वी नीड, सी सम अमाउंट ऑफ ग्लिसरॉल इन 500 ग्राम, ठीक है? सो वही हमको क्या निकालना है? सम निकालना. सम फॉर सम वी विल नीड ईच एंड एवरीथिंग. सो व्हाट डू वी नीड? फर्स्ट ऑफ ऑल यू विल फाइंड आउट दी मोलर मास ऑफ बी. ग्लिसरॉल का मोलर मास कितना हो जाएगा? कार्बन है 3 कार्बन, 12 दिया 36 और 8 44 16 दिया 48 और 44 92 92 grams per mole. Now WA is how much? Mass of solvent is 500 grams that we are taking, and they are asking what is the WB. ये हम लोगों को नहीं पता है. अच्छा, have they, अच्छा they have not given ना. KB आप लोग को हमने यहाँ पे KB दिया हुआ रहेगा, ठीक है? लिखा नहीं हमने. KB will be equal to 0.52 लेके चलते हैं, जो कि पिछले सवाल में था. 0.52 Kelvin kg per mole. कहीं पे लिख लीजिएगा आप साइड में, ठीक है? KB has been given, it is equal to 0.52 Kelvin kg per mole, ठीक है? Now what is delta TB? It is equal to TB minus T naught B, ठीक है? अच्छा, यहाँ पे ध्यान रखिए, all of you know ना, the difference if I calculate in terms of Kelvin या difference if I calculate in terms of degree Celsius, both of these will be equal. Yes or no, please tell me. दोनों बराबर होगा.
Yes, sir.
All of you know this. जिन लोगों को नहीं लगता ना, they what they should do, they should write. अच्छा, what will be the TB? TB इज इक्वल टू 142 है ना, 100 डिग्री 42, सो 100.42 डिग्री सेल्सियस हम लोग क्या ऐड करेंगे 273.15, कितना हो जाएगा 5 2 7 4 1 5 3 7 2 1 3, so be equal to 373.57 minus T नॉट बी इज इक्वल टू हाउ मच 373.15, इसको जब आप डिफरेंस कैलकुलेट कीजिएगा दिस विल बी इक्वल टू हाउ मच 0.42 डिग्री, है ना, इतना ही होगा। अगर आप इसको ये भी लेके चलते 100.42 माइनस सॉरी 100.42 माइनस 100, ये भी आपको कितना आता 0.42 ही आता, ठीक है 0.42 ही आता। यू कैन डू द बोथ थिंग्स, अगर आपको डिफरेंस जहां पे भी लेना रहता है either you take Kelvin or degree Celsius, the value will be equal, okay, the value will be equal। लेकिन हाँ हम लोग यूनिट्स में लेके चलेंगे, केल्विन में ही लेके चलेंगे, है ना, we are more interested in the unit which is Kelvin। Okay, now we have got the delta TB also, we have got the delta TB also, and you know that delta TB is equal to KB into M, है ना, KB into M, हमने यहीं पे प्रूव किया हुआ है आपको this formula, KB into 1000 into WB upon WA into MB, ठीक है, what is KB? KB into 1000 into WB upon 1000 into WB upon WA into MB। अब यहाँ पे बस आप क्या कीजिए WB को आपको निकालना है ना, you have to calculate what is the mass of glycerol that we have added, so WB will be equal to delta TB into WA into MB upon KB into 1000, डेल्टा TB आया 0.42, WA जो आया हमारे पास कितना है WA 500 ग्राम्स इनटू MB हम लोगों ने निकाला है 92, ठीक है, लेट अस इग्नोर द यूनिट्स, वी डोंट नीड नाउ। यहाँ पे ये कितने में होगा, दिस विल बी इन केल्विन, दिस विल बी इन ग्राम्स, 92 विल बी आल्सो इन ग्राम्स, राइट, 92 MB है ना यहाँ पे, सही है, सही है, grams and grams, and this will be grams per mole, MB आपको grams per mole में होगा। KB is how much 0.52 into 1000, यहाँ पे 0.52 जो है वो किस में है, that is in Kelvin kg per mole, so एक पर मोल से एक पर मोल तो चला जाएगा, ठीक है, केल्विन से केल्विन चला जाएगा, राइट, you have 0.42 into 500 into 92 divided by 0.52 into 1000, ठीक है, तो यहाँ पे फिर से क्या है आपके पास, यहाँ पे फिर से आपके पास है 1000, yes or no, look here this one, this is again kg, now we want this in terms of grams, right, we want this in terms of grams, then you have to again do what, you have to again divide by 1000, ठीक है, then this k will be there, we'll just have grams, and here you have grams and grams, 2 grams are there, so 1 gram will cancel the other gram and you are getting all the answer in terms of grams, वो भी सही है because यहाँ पे WB है हमारे पास, please you can calculate now 0.42 into 500 into 92 divided by सही है ना, हाँ सही है, 10 to the power 6 आ जा रहा है, तो ज्यादा कम नहीं हो जाएगा WB, कैलकुलेट कीजिए, तो इसको कैलकुलेट कीजिए, यूनिट तो सही है, WB is equal to, ये भी I think this is right only ना, WB will be equal to how much, WB will be equal to 1000 और KB नीचे आ जाएंगे, ठीक है, WA और MB ऊपर चल जाएंगे, ठीक है, ये भी Oh, I think I have messed up one place. The place where I messed up was I had to take this in terms of WA in terms of K, like जो भी kg में दिया रहता उसी को लेना था हमें. I had to take this as 0.5 और यहाँ पे kg हो जाता. Then both of these should have got cancelled. Wait a second, okay. This WA na here, it should be whatever was there in terms of kg. ये हमको लेना था आपका 0.5. This should be 0.5. तब आपका क्या होता? 0.42 would have been Kelvin times kg times 92 is what? Grams per mole. In the denominator 0.52 Kelvin kg per mole, Kelvin kg per mole, and this 1000. It will be for gram. नहीं, ये Kelvin kg per mole हो गया. ठीक है? Now we can cancel. Kelvin gets cancelled here, kg gets cancelled here, mole inverse gets cancelled here. ठीक है? ये 1000 जो हमने लगाया ये गलत है. This will be like this only. Kg is going to get cancelled. You will get this as grams. I think the answer किसी ने एक भेजा है. Khalid 0.0371 ना, ये हो जाएगा 37.1 ग्राम. Okay. So the value of WA it will be in kg only. That the value of WA will be in kg only. उसी को ठीक करने के लिए we have done here 1000. 37.1 gram will be the answer. यहाँ पे हमने कुछ गलत तो नहीं लिखवा दिया? नहीं. यहाँ पे मास ऑफ सॉल्वेंट इन केजी ही लिखिए इसको. केजी में जब 1000 से डिवाइड करें तो ग्राम खुद ही हो जाएगा. ओके, आई थिंक यू हैव रिटन दिस बट ना. यहाँ तक लिख लिया तो यहाँ पे एक
Yes,
करेक्शन
sir,
ये
yes.
कर लीजिए, है ना. यहाँ पे एक
Okay.
बस करेक्शन कर लीजिए.